we were looking last day, and I was giving you what seemed like a very complicated way to convert one unit to another unit. And Morgan, if you have a method that works for you and you can always get the right answer, you can do it how you want. The risk is I'm going to slowly increase the level of difficulty. You may come a point where your method no longer works, and I do know that this building a conversion chain of fractions method works for anything. Works for anything. Even bailed me out on second-year calculus test one time. Okay? So I'll be honest, for basic metric conversions, because I'm old and teach science, honestly, I do most of them in my head without building a conversion chain. And Colby, if you get that, good, great. If you ask me, can I go from kilometers to meters? Yeah, it's times 1,000. I've just happened to have memorized that shortcut because I drive. If you're asking me, can I go from milliamps to amps because I teach physics? Yeah, I can do that without showing any work. But if you ask me, have I memorized how many seconds there are in a day? No, I can derive it in 1 second by building a chain. If you ask me, have I memorized how many hours there are in a year? No, I can derive that. Or, if you ask me, here's where we left off, 60 miles an hour, what's that in meters per second? It's a good question. I always start out by saying, does anybody know how many meters per second there are in a mile per hour? Okay. Because I'm old, I have a rough guess rule of thumb. If you're going from miles per hour to meters per second, it's roughly divide by 2 and a bit smaller. I'm going to tell you right now, what's 60 divided by 2? The answer is going to be a little less than 30. In fact, if you wanted me to put a bet down, I'll bet you it's going to be around 26, 27-ish. I have that built-in fudge conversion factor. I can do that because I'm a nerd and I actually do like to calculate these things out when I'm sitting around. But let's prove it. How are we going to start? How did we start every single other question? Do you remember? I'm going to write down what they gave me. What did they give me? Now, here's what I'm never going to do, and this is what I never want to see from you. I never want to see fractions written slanty. Fractions should have a clear top and a clear bottom. I'm going to write it like this. 60 mi over h. This way I know what's on the top and what's on the bottom. There is no easy way to do this all at once. We have to do this in chunks. I need to change hours to seconds. That's the unit of time. And I need to change miles to meters. That's the unit of distance. Doesn't matter which one you do first. So Mackenzie, pick. You want to go change hours to seconds or you want to change miles to meters? I don't care. All right. So let's put our little times fraction bar. Where is hours in my original fraction, on the top or on the bottom? So for it to cancel, I want to put it on the, yes. Do you know how many seconds are in an hour? Now, some of you might know, I did have one kid in my other block who said, I've memorized there's 3,600 seconds in 1 hour. They have a conversion factor that you don't need to memorize, but if you happen to have it at your fingerprint, great. So Mackenzie, do you know how many seconds there are in an hour? What can you convert hours to? Yep. So I'm going to put minutes on the bottom. How many hours is how many minutes? And that's how I know the 60 goes on the bottom. That's how I know I'm going to end up dividing by 60 somewhere along the way. It's on the bottom. That takes care of hours. Now we're in minutes. We want to get to seconds. Do you by chance know how to go from minutes to seconds? I bet you do. So where is minutes in my original fraction right now? On the? So where is it going to go in my next fraction? Yep. And this gets rid of the guesswork of, do I multiply or do I divide? What am I going to put on the bottom underneath minutes? And you'll notice seconds is on the bottom. Look up, look up, look up. Seconds is on the bottom in this fraction too. That's where I want it to end up. My chain has taken care of all the placement. Is it 1 minute is 60 seconds? Yes? If we stopped here, we would have miles per second. Do we want miles per second? What do we want? Okay. This I don't have memorized, but you have the chart on your page. What can I change miles into? Is there a kilometer conversion there? The only thing I got is this stupid one here. Yeah? Okay. Where's miles right now originally? On the, where's it going to go on my next one to get it to cancel? On the, and I guess I can go feet. 5,280 is 1 mile. What a dumb conversion factor. This is why I don't like the imperial system at all. Metric is nice. It's all tens. You okay with that, Hannah?
There's a centimeter conversion rate.
What? Hannah, what?
Number 9.
Are you saying if I was clever, I could have looked back one question, and instead of going from miles to feet, I could have gone from miles to centimeters, and going from centimeters to meters isn't the trick at all? I can do that pretty quick? Yeah? You want to use Hannah's trick? I love my digital eraser. You guys just have to cross it out. Sorry. And I have no problem with that. If you happen to have a conversion factor somewhere else on the page, use it. Now, if I didn't have number 9, I would have gone from miles to feet to inches to centimeters. But for now, miles on on the bottom, Mr. Dewick. Centimeters on top, and I guess it's 160,934. Thank you for noticing that, by the way. I was hoping somebody would, but I wasn't going to say anything. Is 1 mile. And Geo, that would leave me in centimeters per second. Do I want centimeters per second? No, I want meters per second. Where is centimeters going to go in my next fraction? Bottom. Meters on top, and now we're in the metric realm. Centi, the letter C, is the same as 10 to the what from your green sheet? It's not. Look carefully. It's not 100. It's not 10 to the 2. I don't think it is. Isn't it 10 to the negative 2? It's 10 to the negative 2. Okay? It's 10 to the negative 2. Where is that 10 to the negative 2 going to go? Where the letter isn't in front of the base unit, not where the centi is. It takes the place of the centi up there. And that takes care of, by the way, multiplying the top by 10 to the negative 2 is the same as dividing by 100, and you were using the shortcut. But the nice thing, this tells you whether you're dividing or multiplying or whatever. So I guess I'm going to go, well, I'm going to ignore the ones. I'm going to go, you can try this on your calculator, 60 times 160,934.4 times 10 to the power of negative 2. And then I think divided by 60 divided by 60. Did I miss any? What was my guess? I said I'm pretty sure it's going to be around 26, 27. How close am I? Let's see. I'm a nerd. I can do this pretty good. Okay. 26. Let's go 26.8. Having said all that, we're almost never going to deal with imperial units. Yes, I know we live close to the US, but I'm going to try and give you metric. The most common conversion you're going to do is you're going to go from kilometers per hour, because that's cars, to meters per second, because meters per second is physics. And we will, since we do that one so often, actually memorize a shortcut, because that's the only reason you should memorize a shortcut, is if you know you're going to be using it so often, you get sick of looking it up. Next page. I had to change this 3 weeks ago because this happened in August. This is the biggest Powerball lottery win ever. You're the first ones to calculate this. Up until now, it was 400 and some million, and so I've always calculated it with that. I don't even know if these numbers will work because this is big. Here's what it says. So and the winner is Mavis Wanchik in this past August landed the largest single lottery jackpot ever in the U.S. You may have heard about it in the news because it did make the news. She won $758.7 million in August 2017. I'm sure you've imagined winning the lottery, and if you have, maybe you've wondered, Just how much money is that? So you ready? If she spends $1,000 per day, how many years will it take to spend the money? Can she do that in her lifetime? I'd kind of like to know. Okay? So here's how we're going to do this. We're going to start out with 758.7 million. Write that down. But we can't do math with English words, so once you've written down million, cross it out. I know that million is actually times 10 to the 6th. That's a million. It's mega. It's why there's one lottery called Mega Millions. It's actually saying millions. On your calculator, type that in. And I get that. Now that's how many dollars she has, but how much does she want to spend per day? So if we divide by 1,000, that's how many days. So here in our notes, divide by $1,000 per day, just so we know what our thinking was. And let's even put a dollar sign in front of the 7 so our units actually match. Is there a dollar sign on the top? Is there a dollar sign on the bottom? Actually, the dollar signs will cancel. You'll actually get an answer in days. How many days? 758. But we don't want to convert that to days. What do we want to convert this to according to this question? Here we go. I want days to cancel. Where is it going to go in my next fraction? On the years. The proper abbreviation for years is a lowercase a, but if you put a y, I'll be okay with it. It's just technically y is yards. What's the conversion factor? How many years is how many days? 1 year. Divide by 365. Can she spend this in her lifetime if she spends $1,000 a day? It was great. When Mackenzie hit equals, I saw your eyes, they went, and you realized just how much money this is. She can't even come close to spending this in her lifetime. You get 2,078 years? 2 millennium? Okay. 2,079 years?
This is not leap years, though.
At this, she said, this doesn't include leap years. At that point, it don't matter. Believe me. What was it, 2,079 years? So let's kick it up a notch. Instead of spending 1,000 per day, what about 500 per hour? Okay. Well, let's again take this 758.7 times 10 to the 6th million, but this time we're going to divide it by $500 per hour, and this will tell us not how many days, this will tell us how many hours, and then we're going to convert that to years. I'm a little skeptical still right now. So I get it's going to take her 1,517,400 hours, 1,517,400 hours. Is that, you get the same thing? So 1,517,400, 1,517,400, that's hours. Let's get that to years. I want H to cancel. Where's H going to go in my next fraction? Bottom. I don't know how many years are in an hour. What can I change hours into, though? Someone remembers from the previous page that there's 8,000. Did we do that on the previous page? 8,700. We did? Okay. Google Drive is now back up in sync. Yeah, okay, got it. So I can go to years. What was the 1 year is how many hours? I'm not feeling good about this. See, oh, I heard a phone, didn't I? Was that my computer? Oh, the computer I can't control, and especially this one's on its last legs. I've told you, I got the power cord for the new one, and apparently they have the new one, but it didn't come with a stylus. I can't write on it. So they're trying to track down a stylus. So I'm hoping maybe by next week. I don't think this is compatible. Of course it wouldn't be, because why would Dell make a stylus that would work on a Microsoft product and vice versa? You want to charge money, right? Same thing Apple does. So I'm going to take this number, and you're saying I divide it by... Yeah. See, the previous lottery winner only won about... I'll say only won about $400 and some million, and so she could actually barely spend it in her lifetime if she lived to be like 95 or something like that. Here, nuh-uh. 173. You know what? We can spend money faster than that if we work at it. So the way lotteries work is normally you have a choice. You can either get the total cash prize paid out over 25 years in installments, or you can get a lump sum up front that's less than the grand prize. Most people take the lump sum up front, which she did. Instead of taking the 758 paid out over 25 years, I'll take the 480.5 million up front. So if she did that, and she spent $10 a minute, I'd kind of like to know. So 480.5 times 10 to the 6th. And we're going to divide it by $10 per minute. That's going to give us an answer in minutes. 480.5 times 10 to the 6th divided by 10. And I get 4805 with 4 zeros. Double check me, is that what you folks get as well? 4805 and then 4 zeros. By the way, good way, if you're writing out numbers with lots of zeros and you don't want to make a copying error, Justin, this is how I would always say it to myself as well. 4805, 4 zeros. That way I don't try and read that. I know it's 48,050,000. Forget it. 4805, 4 zeros. 4805, 4 zeros. And that's in minutes, and we want to convert that to years. 4 zeros. Good gosh. All right. I don't suppose we bothered figuring out how many minutes are in a year anywhere in the notes, have we? Do you know that from the song from Rent? So this is always a wild card. You're not the first person, not the last person. There is a musical called Rent. And in that musical called Rent, there is a song that says, how many minutes? 521,600. If you know that, you can use the shortcut, because you've got a conversion factor that I haven't bothered memorizing. Knock yourself out. I'm going to have to do this the long way. So I'm going to go cancel minutes, get hours, 1 minute, 1 hour, 60 minutes. But I can go from hours to years, can I not? Hours, years, it was 8,760. Sorry, 1 year is 8,760. The 800,760 goes on the bottom. You'll have to figure out how your conversion factor works, but you should just match up the units very carefully, and that'll tell you where the 500 number goes, whether it goes on the top or the bottom. I suspect on the bottom, if I'm doing the math right in my head. So this number is going to be divide by 60, divide by... Can she do this in her lifetime? If she won the lottery when she was young, and she lives to a ripe old age, wait a minute, must be at least 21 years old to play.
She's 53.
She's 53, she's out of luck. This goes back to at the very beginning of the year when I showed you that Mega Penny project little web page. These numbers are so big, it's just tough to wrap our brain around them. They really are. But I've tried to give you some kind of context here. Well, 91.4 equals 91.4 years. Next page. Enrico Fermi was a physicist who was very famous for doing very, very complicated calculations in his head by making a rapid series of rough estimates. For example, he was one of the people working on the original Manhattan Project. That was the original atom bomb that was built during World War II. And he was at the very first atom bomb test, what we call the Trinity Test, because of the Trinity site. And he held up a piece of paper like this, and as the blast wave hit him, he let it go, and by noticing how far back it flew, he thought for about 5 seconds, and he was able to come up with a pretty accurate estimate of how big the bomb was. He was very clever at doing things like that. In fact, he was so clever, we have named these after him. We call them Fermi Problems. The idea behind a Fermi problem was you try and come up with a reasonable mathematical argument, and you want to get your answer within an order of magnitude. Say, what? That means if you wrote your answer out in scientific notation, the 10 to the would be correct. You don't care about the front part, but the 10 to the would be correct. So, as part of your homework, and I'm not going to assess this, if you want to, you can try the following 2 Fermi problems. First, I got a video to show you. Put your pencil down, look up. If you want to try, if you feel like it, try and come up with a Fermi estimation for the following 2 questions. I'm not going to collect this or assess this. Instead, next class, I'm going to ask if anybody wants to convince me of their argument. First one, if Pitt Meadow Secondary School has 1,100 students, how many pieces of note paper does our entire student body use in an average year? How much binder paper? And see if you can come up with an argument with an order of magnitude. This one I like. I've had kids come up with a whole bunch of different methods, but it's funny, each of them ends up being close to the other person's answer, which suggests we're probably pretty close. Second, how many breaths are taken each day in BC? Oh, as soon as I said that, I watched about 12 of you, as a reflex, took a breath. That was funny. That's a good, oh, I just, okay. That's not your homework. That's for fun. What's your homework? Here it is.